Welcome to the deep dive. Today we're digging into something new in LIRA-CAD. Something I think a lot of you structural engineers might find interesting, the expertise of reinforced concrete structure system.
Exactly. Yeah, the standard way of designing reinforced concrete automatically, well, it had quite a few steps.
Right.
You had your modeling, then the finite element model, which was often, idealized.
Simplified, maybe.
Yeah, simplified. Then selecting the reinforcement, detailing, and finally that really critical step, verification.
And that could take a while, going back and forth.
Oh, definitely. It was often iterative, and sometimes the reinforcement numbers you got theoretically didn't perfectly, let's say, mesh with the final practical design.
Okay, so this new system in LIRA-CAD, the expertise of reinforced concrete structures. What's the core problem it's aiming to fix for engineers?
Well, basically, it gives you a dedicated space right inside LIRA-CAD just for checking your concrete and reinforced concrete structures against the regulation.
Right.
It makes that vital verification part more direct, more streamlined.
So it's not purely a final sign-off tool, then. Can you use it earlier on?
Absolutely. Yeah, while that final check is key, you can definitely use it for, say, local calculations on just one beam or column, or checking some preliminary reinforcing ideas early in the design.
Okay.
And even looking at existing buildings, maybe for renovation work or strengthening.
Interesting. So our mission today really is to unpack the benefits of this expertise of reinforced concrete structures feature within LIRA-CAD. Where should we start? Maybe setting up a calculation.
Sounds good. Yeah, the system lets you be very explicit about the calculations you need. You specify the exact check you're doing.
Like a strength or cracking.
Exactly, like a normal section strength check or maybe a crack resistance check. You define the load combinations to use, which structural elements you're focusing on,
Right.
and the material properties you need for that specific calculation, all following standards like, say, Eurocode EN 1992.
It sounds very targeted. I think I saw something about tags being used. How do they fit in?
Tags. Yeah, they're really useful. Think of them like labels.
Okay.
You can tag load combinations, elements, materials, basically anything. And then you link these tags to your calculation tasks.
So if a task has a certain tag.
It automatically uses all the loads, objects, and materials that have the same tag. It's a really neat way to keep things organized, especially on bigger projects. Cuts down on, potential errors from manually assigning everything.
Yeah, I could see how that would streamline things.
Yeah.
Makes sense.
Right.
Now, what about defining the properties of the elements you're checking? The beams, the columns themselves.
Right. That's handled by what are called design property sets.
Okay.
Their job is to define the specific design characteristics needed for the objects, but specifically in the context of the calculation task you're running.
So different checks might need different properties defined.
Precisely. Different task types use different kinds of property sets. The workflow is usually create the sets you need in the project library first, and then you assign them to the actual design objects in your model.
Could you give us an example, maybe comparing a column and a beam?
Sure. Let's say you're doing a normal section strength check. For columns, you'd likely create a property set that considers things like geometric imperfections, maybe second-order effects, minimum eccentricity.
Things more critical for columns.
Exactly. But for beams in the same check, you might use a different property set where those specific effects aren't considered because they aren't relevant for that check on a beam.
I see.
And you'd have other specific sets if you were just analyzing, say, crack resistance or just geometric imperfections. It tailors the analysis.
Got it. So it ensures the right factors are considered for the right element and the right check. Makes sense. How about materials? How does the system handle concrete and steel properties?
Good question. The expertise of reinforced concrete structure system actually uses its own set of calculation materials for these checks.
Oh, interesting. Separate from the main LIRA-CAD library.
Yes, it's a dedicated set for this verification purpose. You can build them from scratch if you need to, but often it's easier to just load them from a user database or the built-in standard libraries.
Like loading a standard concrete grade.
Exactly. You could, for example, load a Class C 2025 concrete directly from the Eurocode database provided within the system.
Okay.
And a key concept here is material behaviors. Within each material definition, you can have multiple behaviors.
Behaviors, what does that mean?
Think of a behavior as a specific set of design characteristics for that material. tailored for a particular calculation situation.
So link to the task again.
You got it. Tags again. You use tags to link a specific material behavior to a specific calculation task, so the task pulls the right material properties for that check.
Yeah.
And you can create new behaviors, edit them, delete them, whatever you need.
So you might have different design strengths for the same concrete depending on the check.
Potentially, yes, based on code requirements for different situations. The examples also mention loading, say, C30337 concrete or B500A reinforcing steel.
This tagging system really seems to be the glue holding it all together efficiently. So you've set up tasks, properties, materials. How do you actually bring the structural model into this expertise environment?
There's a model overview dialog. It gives you a nice, clear, sort of hierarchical tree view of all your design objects and their properties within this system.
Okay.
To actually add elements from your main LIRA-CAD model, it's pretty straightforward. You just select the structures you want in the 3D view.
Right.
And click a button like Create Structural Elements from Selected. They then appear in the expertise systems model.
And then you link them up.
Yep. You'd select those elements, maybe all your columns, for instance, and assign them the tag that connects them to the calculation tasks you set up earlier.
Got it.
And finally, you assign the right concrete, the right reinforcement materials, and those calculation property sets we talked about, all matched up through the tasks and tags.
Okay, so model elements are in, linked to tasks, properties assigned. What's the next piece of the puzzle?
The loads. Exactly. You need the loads and, crucially, the internal forces, the moments, shears, axial forces.
Right. Where do they come from?
You import them, typically from a LIF file. That's the LIRA-FEM file, the results file from the finite element analysis run in LIRA-CAD.
Okay.
When you import this, the system automatically creates calculation sections within the expertise of reinforcing concrete structures environment for all your elements based on the FEM results. And the load combinations are set up based on the relevant standards, like RSN.
Does it show you what's being imported?
Oh, yes. There's an import dialog that clearly shows you the mapping, section IDs, load combination IDs, the status. You can even make manual adjustments if needed.
Good.
And once they're imported, you can view the forces and the combinations in their own dialog windows. And, crucially,
Let me guess. Tags.
you know it. You assign the necessary tags to the imported load combinations to link them to your calculation tasks as well.
Okay, makes sense. Everything seems connected. We're finally ready to run the checks then. What do the results look like?
Yep, time for the calculation. The main output is usually shown as a mosaic, like a color map, of utilization coefficients right on your 3D model.
So you get an immediate visual overview.
Exactly. It instantly shows you which parts are working hard, which have plenty of capacity, based on that utilization factor for each calculated section. And you can filter this view.
How so?
Well, in the display settings, you can choose to see the mosaic for just one specific task or one specific load combination or a combination of those. Focus on what you need to see.
Okay, that's useful for a quick overview. But what if you need to see the details? Like, why is that column showing 95% utilization?
That's where calculation tracing comes in. It's really powerful.
Okay.
You can select an element or even a specific section in the 3D view. Then you pick the task and combination you're interested in and request the tracing.
And what does that show you?
It shows you the works, the actual formulas used in the calculation based on the code, the algorithmic steps. And it shows them both symbolically and with the actual numerical values plugged in from your model and loads.
Wow, okay.
So you can literally trace every single number in the result right back to the input data. It gives you complete transparency into how the system arrived at that utilization factor.
That sounds incredibly valuable for verification and just understanding the design.
Absolutely. You could use it to check, say, the normal section strength of your columns, or maybe check a slab using DBN requirements, that's just an example code, and see exactly how forces determined by, say, the wood armor method were used in the check. Full traceability.
That level of detail is fantastic. Now, you mentioned this is a relatively new system. What's the roadmap? What's coming next?
That's right. It's still in its early stages of rollout. The developers are very keen on getting user feedback to shape where it goes next.
How can users provide that feedback?
They have a specific section on their website, apparently called Chefwas, which translates to "there is an idea." Users are encouraged to submit suggestions and requests there.
Good to know. Any specific plans they've mentioned?
The general direction is definitely towards adding more types of checks, covering a wider range of regulatory codes and design methods, and also ongoing work on the user interface, making input and results analysis even smoother.
Okay, so it sounds like a really promising development for LIRA-CAD users doing concrete design. If we were to sum up the key takeaways, what are the biggest advantages here?
I'd say the main things are, first, the potential for significant time savings in the verification stage, and second, improved confidence in meeting regulatory compliance.
Right.
Having this dedicated, organized, and transparent environment for checks right within the main software, it just makes the workflow much more efficient and reliable. The tagging, the explicit tasks, that detailed tracing, it all adds up.
It definitely sounds like it tackles a common pain point. Well, here's a final thought for you listening. If you have tools like this, tools for detailed verification, integrated much earlier and more directly in the design workflow, how might that change the way we approach design itself? Could it lead to solutions that are not just compliant, but perhaps more optimized, more inherently robust from the start? Something to think about. Definitely worth exploring LIRA-CAD and this new expertise of reinforced concrete structure system if you work in this area. Thanks for joining us on this deep dive.